Introduction to coordination compounds. So, coordination compounds means metal ion coordinated with such type of molecules like ligands. The type of compounds are known as coordination compounds. For example, this is one of the example for coordination compound. This complex is observed. Central metal atom is iron. Generally, coordination compounds, central metal atoms or central metal ions are involved for D block elements. Due to so many reasons are there. D block elements are exhibit some special characteristics. These are exhibits multiple oxidation states. These are exhibits more reactivity character. These are exhibits some colored property. These are exhibits high melting points and high boiling points. These are exhibits formation of interstitial compounds. These are the special characteristics of D block elements. These points are based on these elements are exhibits more reactive character than compared to other elements in modern periodic table. But these points are based on these elements are used for central metal atom for the different coordination compounds. Finally, the coordination compound means metal atom or ion coordinated with different molecules or ligands. This molecule or this part is observed in closed brackets. That is known as coordination sphere. This type of compounds are known as coordination compounds. Okay. First coordination compound is a Persian blue color liquid. For example, blue color ink. Blue color ink. This is a first coordination compound. This is exhibits Persian blue color. Persian blue color. This is exhibits Persian blue color solution. This compound chemical formula is KCN, FeCN twice, FeCN thrice. This is a first coordination compound. Generally, this compound exhibits Persian blue color. So, the central metal atom iron coordinated with the different monodentate ligands or cyanide ions. Okay. So, anyhow, this compound is observed. The central metal atom coordinated with different types of molecules. That molecules are known as ligands. Okay. This type of compounds are known as coordination compounds. Okay. These are known as coordination compounds. Why? What is the reason? The central metal atom coordinated with the different molecules or ligands. For example, this is a central metal atom, iron. This atom coordinated with cyanide molecules, Cn minus, cyanide molecule Cn minus. So these Cn minus ions or cyanide ions are known as monodentate ligand. Monodentate ligand means this type of ions are donated one pair of electrons with others. That type of ligands are known as monodentate ligands. In this complex, in this coordination compound, the central metal atom coordinated with ligands. This type of compounds are known as coordination compound. This is known as coordination compound. And next one, these compounds are observed, means coordination compounds are observed. Mainly two types of compounds are there. These two compounds are similar, means central atom coordinated with different ligands. Okay, central atom coordinated with different ligands. The type of compounds are known as coordination compounds. In these compounds are observed two different compounds are there. First category is double salts. Double salts. First category is double salts. And the second category is coordination compounds. Coordination compounds. Simple coordination compounds and double salts. Both are observed like double salts and coordination compounds. Both are observed. Both are central metal atom coordinated with different ligands. This property is exhibited in these two compounds, but what is the difference between double salts and coordination compounds? Both are similar, means in these compounds central metal atom coordinated with the different ligands, but some difference is there in these two compounds. The difference is double salts means double salts is diluted. Double salts is diluted to produce different cations. For example, more salt. So, more salt is observed. More salt is the best example. More salt. FeSO4, NH4 twice SO4, 6H2O. This is a chemical formula for more salt. So, in this more salt react with water, it's dissociated two cations. That cations are like iron Fe+2 and ammonium NH4 plus. Different cations are produced. So, in these two, initially this more salt is observed. So, sulfate is common anion. FeSO4, NH4 twice SO4, 6H2O. Sulfate anion is common, but this compound react with water, it is dissociated into two different cations. It dissociates into two different cations. This type of compounds are known as double salts. These are known as double salts. Okay, what is the meaning of double salt? Double salt is also one of the coordination compound, but this molecule is exhibits some special character. That is, this salt react with water, it's dissociated into two types of cations. That type of coordination compounds are known as double salts. And next one, coordination compound. For example, FeH2O 6 plus 2. This is a positive charge coordination compound. This compound react with water, do not dissociate it. Means do not produce different types of cation. Do not produce different types of cation. Okay, this type of compounds are known as coordination compound. This type of compounds are known as coordination compound. Another example for double salt is observed. KCl, MgCl2, 6H2O. This is another double salt. These salts react with water. It's dissociated into two cations, K plus cation and Mg plus 2 cation. These salts like cornolite, KCl, MgCl2, 6H2O. This salt is known as cornolite. This is a double salt. Why is known as double salt? So in this compound react with water. This compound dissociate into two types of cations, but anion is same. These type of salts are known as double salts. And next one, another example for coordination compound. So in this coordination compound, another example is K4 FeCN6. This is another example for coordination compound. This compound react with water. This compound react with water. Only Fe plus 2 ions are dissociated. Do not dissociate two types of cations like potassium ion and Fe plus 2 ion. Both are do not dissociated. Only it produces Fe plus 2 ions. So this type of compounds are known as coordination compounds. This type of compounds are known as coordination compounds. Finally, the given compound react with water. It's dissociated into two cations. That type of compounds are known as double salts. The given compound react with water, do not dissociate it into different cations. The type of compounds are known as coordination compound. That is the difference between double salts and coordination compounds. Now, I am going to discuss coordination compound. I am going to discuss coordination compound. What is the meaning of coordination compound? Central atom coordinated with ligands. The type of compounds are known as coordination compounds. The coordination compounds are subdivided into three categories. First one, positive charged coordination compounds. Positive charged coordination compounds. Positive charged coordination compounds. Second one, negative charged coordination compounds. Second one, negative charged coordination compounds. First one, positive charged coordination compounds. Second one, negative charged coordination compounds. Third one, neutral charged neutral charged coordination compounds. First one of the example for positive charged coordination compound. So generally the positive charged coordination compound is Fe H2O 6 plus 2. This is a best example for positive charged coordination compound. This compound is observed the net charge is plus 2. The net charge is positive. The type of coordination compounds are known as positive charged coordination compounds and negative charged coordination compounds. Negative charged coordination compounds. For example, the negative charged coordination compound is platinum coordinated with 4 chlorine atoms. Finally, the net charge is minus 2. The net charge is minus 2. So this is a plus 2 charge. This is minus 4. The net charge is minus 2. Plus 2 plus minus 4 is equal to minus 2. So in this positive charge coordination compound is observed. So iron is exhibits plus 2 charge. Water molecule, this is a neutral ion 0. So plus 2 plus 0, the net charge is plus 2. So the net charge is plus 2. This type of compounds are known as positively charged coordination compounds. And another coordination compound like PT, platinum coordinated with 4 chlorine ligands. This type of coordination, this compound, the net charge is equal to minus 2. Due to platinum is individually exhibits plus 2 charge. It's coordinated with 4 chlorine atoms. Plus 2 minus 4 is equal minus 2. The net charge is negative. The type of coordination compounds are known as negative charged coordination compounds. And another example is taken. Platinum bind with 2 moles of water molecule and 2 moles of chlorine atoms. In this complex, individually platinum is exhibits plus 2 charge, water is exhibits 0 charge, means this is neutral ligands, water, carbonyl CO and NH3. So these are the neutral ligands. The charge is expressed as 0. That point is based on this is known as neutral ligands. And minus 2. Chlorine 2 chlorine atoms. Finally minus 2 charge is exhibited. The net charge is plus 2 plus 0 minus 2. Plus 2 minus 2 is equal to 0. The net charge is 0. Net charge in this coordination compound is equal to 0. The net charge is equal to 0. The type of compounds are known as neutral coordination compounds. Neutral type coordination compounds. These are the different types of coordination compounds. And next one, which type of molecules are formed coordination compounds? Only few molecules are formed coordination compounds. All molecules do not produce as coordination compounds. Why? What is the reason? I discuss which type of molecules are formed coordination compounds. For example, one of the complex is taken. So K4 potassium ferrocyanate K4 FeCN6. This is one of the coordination compound. This coordination compound, central metal atom is act as Lewis acidic character, means this metal atom loses some electrons. This point is based on this is act as Lewis acid. Okay, this ion containing some vacant orbitals. Vacant orbitals. The vacant orbitals energy is denoted as E2. Vacant orbital energy is denoted as E2. And next one, these are the ligands. These are the ligands. So the central metal ion coordinated with different ligands. In this coordination compound, cyanide ions are known as ligands. So the ligands orbital energy is denoted as E1. So the central metal atom vacant orbital energy is denoted as E2 and the ligand orbital energy is denoted as E1. Okay. To assume ligand orbital's energy is denoted as E1 and central metal ion vacant containing some vacant orbital, that orbital energy is denoted as E2. Okay. In this coordination compound, two parts are there. First one is central metal ion and the second one is ligands. The central metal ion containing some vacant orbital, this vacant orbital energy is denoted as E2 and the ligands orbital energy is denoted as E1. Only the E1 minus E2 is equal to very small value. Very small. E1 minus E2 is equal to very small value. Means near about 0 to 1. Near about 0 to 1. So means this energy is very small, not this value in between 0 to 1, this value is very small. These two energy levels energy level difference is very small. That type of molecules are formed coordination compounds. Okay. So in these two energy levels difference is very small. The type of molecules are formed coordination compounds. And the remaining molecules do not produce the coordination compounds. Okay, this is an explanation for suitable molecule for the formation of coordination compounds. Which type of molecules are formed coordination compounds? That molecules, central metal atom, vacant orbital energy, and ligands orbital energy, both energies differences are very small. Only that type of molecules are formed coordination compounds and remaining molecules do not produce coordination compounds. Okay, this is a introduction for coordination compounds. First of all, I explain a few points. Introduction to coordination compounds. Just first one, what is the meaning of coordination compound? What is the difference between double salt and a coordination compound? Next one, classification of coordination compounds on the basis of net charge. And next one, which type of molecules are formed coordination compounds?